In this video, we are going to use Riemann sums to estimate area under a curve. In this first type of problem, they are giving us a picture of the function f of x equals negative x squared plus 10, and they have gone ahead and drawn rectangles underneath the graph that we're going to use to find the total area. Now, notice we're only going to look at the region from -2 to +2 based on the rectangles they have drawn. And while there are some gaps in here, you'll notice that there are places where the rectangles are bigger than the curve. And so this is a way we can estimate how much area there is between the curve and the x-axis by using these rectangles. So if we think back to geometry, we know that the area of a rectangle is going to be found by taking the base times the height. You do have to pay special attention to how the x and y axis are laid out so that you can get the base and height correctly. Correct. So, for example, if you look on the x-axis, if this is a 2, then this would be a 1. So each unit on my x-axis is a half. So, but bottom line is that each of these bases of these rectangles are going to be 1 unit. So the bases of all the rectangles are 1 unit. Now, when I look at my y-axis, you'll notice that the y-axis increments are all by a whole unit and not a half unit. So when I look at the height of this rectangle here, it has a height of 9. The second rectangle here has a height of 10. This third rectangle has a height of 9 again. And this fourth rectangle only has a height of 6. So if we calculate the individual area of each of our rectangles, rectangle number 1 had a base of 1 and a height of 9, so 1 times 9 is an area of 9. Plus rectangle 2 has a base of 1 and a height of 10, so 1 times 10 is 10. Plus rectangle 3 has a base of 1 and a height of 9, so 1 times 9 is 9. Plus rectangle 4 has a base of 1 and a height of 6, so 1 times 6 is 6. So now if we add all of those areas together, 9 plus 10 is 19, plus 9 is 28, plus 6 would give us a total area of 34 square units. The second type of problem is not going to provide us with the graph. They're going to just tell us what the function is. It'll be the same type of function, so we know it's an upside down parabola. And so we'll kind of sketch it here. Notice in this case it's 81 minus x squared, so what that tells us is that this would reach a height of 81, and then on our x-axis it's going to be crossing at +9 and -9. So 1, 2, 4, 5, 6, 7, 8, 9. And then on the other side, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know we have a picture that looks something like this. Okay. Now, the second thing that they're going to tell us is what area we're looking for. So in this case, from -9 up to +3. So that's where our rectangles will start, and that's where they will stop. And then they're going to tell me how many rectangles. And so if you look at the distance between -9 and 3, that's a distance of 12 divided by 4 rectangles means that each rectangle will have a width of 9. They also give us some C1 values, and basically that's just going to tell us where that particular rectangle is hitting our curve. So on this first rectangle that starts at -9, 8, 7, it's going to end at -6. So if we go ahead and just kind of roughly sketch that rectangle, what they're wanting us to do is at -8.5. So actually right there, I went a little too high. That's where they're wanting us to cut off the rectangle and let it hit the curve. So that, notice it gets pretty close to, it's a little bit over the curve, but it gets pretty close to the curve. So on my second rectangle, all right, So it'll go from -6, 5, 4 to -3, and what they're wanting is they're wanting it to hit the curve at -5.5. So again, I went a little bit too high there on the right. Okay, but notice again, so there is a little bit of a gap, but hopefully between the overlaps, that kind of cancels each other out. And again, it's just an approximation tool. So my third rectangle, we know will go from -3 to 0, but they're wanting me to hit the curve at -2.5. So it's going to come up here like that. And then my last rectangle will go from 0 to 3, but they're wanting it to hit the curve at 0.5. So that would be about right here. So it's going to come up and go a little bit over. So there are my 4 different rectangles. Again, you're going to do just like you did on the previous and find the area of each rectangle. So the base of each rectangle is 3. And in order to find the height, I'm going to have to actually take these values where it's hitting the graph and plug each of those values into the original function. So with a calculator, I'm going to say what is 81 minus a -8.5 squared, and that would give me a height of 8.75, okay, because that's where the y value would be there on the graph. So now, if I said what's the area of this first rectangle, I am multiplying a 3 for the base times a height of 8.75, and I'm getting an area of 26.25 on the first rectangle. As I go to my second rectangle here, again, its base is 3, and since they told me to let it hit the graph at -5.5, I'm going to plug -5.5 into my function. So 81 minus a -5.5 squared is going to leave me with a height of 50.75. That's where that y value is. So now looking at the area of that particular rectangle, if I take my base of 3 times my height of 50.75, I'm getting an area of 152.25. Now I move to my third rectangle. Again, has a width of 3. This time they told me to let it hit the curve at -2.5. So if I plug -2.5 into my function, 81 minus a -2.5 squared, I now have a height of 74.75. So for the area of that third triangle, if I take my base of 3 times my height of 74.75, that third rectangle has an area of 224.25. And then finally, when I look at my fourth rectangle, my base is 3. They told me to let this one hit at 0.5. So if I plug my 0.5 in, 81 minus a 0.5 squared is going to leave me with a height here of 80.75. So for the area of that rectangle, if I take my 80.75, which is my height, times my base of 3, I have a total area of 242.25. So now I'm going to add up those 4 areas, 26.25 plus 152.25 plus 224.25 plus 242.25, and I get a total area of 645 square units. They're just wanting you to say 645. Okay, on the third and final type of problem, again, they'll give you a function. They will give you an interval on which to find your rectangles, and they'll tell you how many rectangles to find. So in this case, we know that it's going to be hitting at 64, and it's going to be crossing at 8 and -8. But we're not looking at that whole interval. We are only looking from -8 to +2. So our rectangles will start at -8 and they will stop at +2. This is a distance of 10. If we divide that by 5 rectangles, each rectangle will have a base of 2. So the first rectangle will go from -8 to -6. The second one will go from -6 to -4. The third one will go from -4 to -2. The fourth one will go from -2 to 0, and the fifth one will go from 0 to 2. And they're telling you to just let the midpoint of each interval be your value for your C of K. So if I first just kind of sketch my rectangle, so there's the midpoint. That would be the midpoint there. This would be the midpoint here. Oops, missed it a little bit. That would be the midpoint there. And then that would be the midpoint there. So again, we're back to looking at each rectangle has a base of 2, and we're going to have to figure out the height of each one. So on this first one, that midpoint is -7. So if I plug -7 in for my x squared, I'm going to get a 64 minus -7 squared would be a 49. So that would be a height of 15, an area of 30 for the first rectangle. And then on the second rectangle, that midpoint is -5. So if I plug -5 into my function, 64 minus -5 squared would be 25. That's going to leave me with a height of 39. So 39 times my base of 2 is going to give me 78 for the area of that second rectangle. If I look at my third rectangle, the midpoint there is -3. So 64 minus a -3 squared would be 64 minus 9. I get a height of 55. 55 times my base of 2 is going to give me 110 for the area of that rectangle. When I look at my fourth rectangle, the midpoint there would be -1. So 64 minus -1 squared would give me 63, and so the area of that would be a base of 2 times a height of 63, so that's going to be 126. And then finally, the midpoint of this last one is +1. So when I plug that in, 64 minus +1 squared is also 63, so that base of 2 times the height of 63 would be also 126. So for my final total sum of my areas, if I take 30 plus my 78 plus my 110 plus my 126 plus my 126, I get a total area of 470.